Factoring trinomials when the leading coefficient is not 1. So in the last section, you had just x squared plus bx plus c, but now there's going to be a number in front of the x squared, which is going to make it a little bit trickier. There's just more steps. It's the same general idea, but there's more steps. So to start with, usually we would just take the last number and figure out what factors we can get to add up to the middle number. But since we have this number out front here, what we're actually going to do is we're going to multiply the coefficient of x squared and then that constant at the end there. We're going to multiply those together, and that gives us 10. And then we're going to list factors of 10. Okay? So some things I can multiply to get 10 would be 1 and 10, and 2 and 5. Okay. Now, which of these two adds up to give us 11? 1 and 10. Okay. Now, before, we could just write x plus 1, x plus 10, and then we're done. But this time, it's going to take a little bit more effort. What I'm going to do is I'm going to write this equation, but instead of writing 11x, I'm going to split it into 1x and 10x. Okay, and basically what I did, when we're multiplying polynomials, we usually multiply and then we have like terms at the end that we combine. Well, now I undid the combining like terms. I was thinking this is probably what it looked like before combining like terms. So I undid that. Okay. Now, we're going to do the factoring by grouping. Remember we did that the first day where we had the first two terms and the second two terms. I'm going to group these. Okay, and I'm going to do the factoring by grouping. So what's something, let's just focus on the first set of parentheses. What's the GCF of 2x squared and 1x? All right, that would just be x. And then when you divide everything by x, that 2x squared goes down to a 2x, and that 1 just becomes a 1. Now over here, the GCF of 10x and 5. That's going to give me 5. Okay. And then 10 divided by 5 is 2, but the x is still there. 5 divided by 5 is 1. And now we're going to factor out. Do you see how these binomials here repeat? We're going to factor out a 2x plus 1. And what we'll have left is an x plus 5. Okay. And now you must be particularly careful to check your work. So take a moment and multiply this back out. And make sure you get 2x squared plus 11x plus 5 as an answer. Okay, if it worked, then we're good. That's our answer. Okay, we're going to do a few more of these because it's a lot of steps. So number 2, okay, first step is to multiply the first coefficient and the last coefficient. So once again, 2 times 5 gives us 10. List all the factors of 10. Well, we already had them up here. 1 and 10 and 2 and 5. Now, which of those factors can we add, okay, to get 7? That would be 2 and 5. Okay. So now I'm going to rewrite the equation 2x squared, but instead of at 7x, I'm going to write 2x plus 5x. And really, if you want to write 5x plus 2x, that's fine, but the only reason I'm putting the 2 first is because it looks like it's going to be easier to find a GCF between 2x squared and 2x rather than 2x squared and 5x. So I'm writing these in order so that it makes it easy for me to find a GCF. So there we go. Now, let's group everything. So there's the first half. Okay, and the second half. Now let's take the first half. The GCF of 2x squared and 2x. What would that be? That would be 2x. And then on the inside, when we divide, 2 divided by 2 is 1, and then we still have an x. 2 divided by 2 is 1, but that x goes away, so it's 1x plus 1. And then what's the GCF of 5x plus 5? It's 5, and then factor that out, and we get x plus 1. And now, we see we have x plus 1 and x plus 1. I'm going to factor that out, and I'll have 2x plus 5 left behind. Take a moment and multiply that and make sure that you get 2x squared plus 7x plus 5 as your answer. All right, if you did, we're good to go. right, step 3. I'm going to make you start telling me the steps here. What do I do first? I got to multiply 6 and 5, negative 5, and I get negative 30. Now I'm going to list the factors of 30. So 1 and 30, 2 and 15, 3 and 10, 5 and 6. And I'm basically just going 1, 2, 3, 4 doesn't work, 5 works, and then I'll loop back. Now I loop back around to 6 when I list all these factors. Okay, now here's the thing, because it's negative 30, remember one of them has to be negative, and deciding which one to make negative, let me look at my middle number here. That's a plus 7x. So in order to add two numbers and get a positive, the smaller one would have to be my negative number. Now, which of those two will add up to give me 7? We have 3 and 10 right here. Okay, so I'm going to use these two. So let me rewrite the equation, and I'm going to have the 3 go first because it will work nicely with the 6 in finding a GCF. The same with the 10 and 5. They'll work nicely together. Now let's group everything. Okay, what's the GCF of 6x squared and 3x? That's going to be 3x, and then I'm left with 2x minus 1 inside. What's the GCF of 10x and 5? That's 5, and I'm left with 2x minus 1 inside. And this is good when you have this repeating. That's how you know you're on the right track. If you get two different binomials here, you might want to take a look at your numbers again. And now let's factor out the 2x minus 1. And now check your work. It's all good. That's your answer. I'm going to keep doing examples of these because I feel like the more you see it, the better you're going to be. All right, this one. So first step, multiply first number and last number. Negative 2 times negative 3 gives me positive 6. Now let's list the factors of 6. We can have 1 and 6 and 2 and 3. Now here's the thing. See how the middle number is negative? The only way we're going to add and get a negative 5 is if these are all negative. And it works out because if you do a negative times a negative, that will give you positive 6. But when you add two negatives, that will give you that negative 5. Now, which of these will add up to give you negative 5? That'd be negative 2 and negative 3. And I'm going to have the 2 go first, because that'll work nicely with that too. And now let's factor by grouping. Oops. What's the GCF of the first set of parentheses? And that would be negative 2. Okay. And when I factor out negative 2, what do I have left in the parentheses? X plus 1. And then what's the GCF here? That'd be negative 3. When I factor out negative 3, what do I have left? X plus 1. And now, do you see anything repeat? The x plus 1. So we have negative 2x minus 3 and x plus 1. And now we're technically not done. Because see how these are both negative? I'm actually going to factor out that negative and make it positive 2x plus 3. And we just do that to make sure that it's factored out completely. Remember when I said you factor it till you can't factor it anymore? Well, I can technically factor this because I can take out the negative. It's like a negative 1. And then we have negative 2x plus 3 and x plus 1. And that's our final answer. Now there is an easier way to do that rather than factoring at the end. If we look at number 5, okay, see how these are all negative like number 4 was? Negative, negative, negative. I'm actually going to start by factoring out the negative from the start. Okay, so I'm going to factor out that negative and make everything positive. And now it's nice when everything's positive because it makes this whole process a little bit easier. Okay. So let's do what we did before. Just ignore the negative for this whole thing, and then at the end you could just throw it back on. So we're still going to multiply 6 and 12, and that gives us 72. And we're going to list all the factors of 72. There's a lot. 1 and 72. 2 and 36. We can do 72 divided by 3 and get 24. 72 divided by 4, yep, you can get 18. 72 divided by 5 doesn't work. 72 divided by 6. 72 divided by 7 doesn't work. 72 divided by 8, that gives me 9, and then 72 divided by 9 gives me 8, so I have loop back around. Okay, which of these sets, when I add them, will give me 17? That would be 8 and 9. Okay, and what I'm going to do when I rewrite this, if I look at the numbers 8 and 9, and I think about how they'll go with 6 and 12, 8's probably going to be a little bit easier with 12, and 9's probably going to be easier with 6. Or, I mean, I guess you could switch them. You could do 8 with 6, 9 with 12. I'm going to do 9 with 6 and 8 with 12. I think if you switch these, you should get the same exact answer. So if you want to pause the video and try switching them and seeing what happens, it should still work out. Okay. All right, now let's group everything. Oops. What's the GCF of 6x squared and 9x? That's 3x, and what will you have left inside the parentheses? 2x plus 3. What's the GCF of 8x and 12? That'd be 4. What's left inside the parentheses? 2x plus 3. So what's my final answer? 2x plus 3 and 3x plus 4. But then don't forget we had that negative in the beginning. So throw that negative back in there. Okay. So my final answer is negative 2x plus 3 and 3x plus 4. I think if you switched the 8 and the 9, you'd probably just have the 3x plus 4 go first. But it actually doesn't matter. As long as you have 2x plus 3 and 3x plus 4 with the negative out front, you can switch these two, and everything will be fine. All right. We're going to work on this more in class, so you will have the opportunity to practice. I know it's a lot of steps, but the more you work with it, the better you're going to be. Okay? There's no your turns on the homework, so just make sure you have all this down to show me next class.